I've been on a mission to create a 3D printed airless basketball that's as close to the Wilson airless basketball or even a real basketball as I can get with regular FDM 3D printing. But out of all the testing and things that I've tried, one of the biggest factors that I've found that makes or breaks a airless basketball is the actual model of the basketball itself. I tried quite a few airless basketball files online, and some of them had good durability but not very great bounce, and then also the opposite where they had great bounce but would eventually crack. Another unexpected issue I was running into is most of the designers of these airless basketball files would only offer one model for all the different filament types out there. And if you want to keep the airless basketball diameter size within the NBA official diameter size, which is one of my goals, then this is going to cause problems because different filaments have different densities, and when it's something small it doesn't make that much of a difference, but when it's an airless basketball, different densities in the filament, if you're keeping it within a certain diameter size, will make the weight of the basketball fluctuate by quite a bit. For example, PETG has a density of about 1.23 grams per centimeters cubed. Regular PLA has about 1.25 grams per centimeters cubed, and PEBA filament has a density of about 1.013 grams per centimeters cubed. That would mean that if you use the same basketball file and kept the diameter and size the same, you would get vastly different weights for the different types of filament. That's kind of a big deal when you're trying to keep the diameter of the ball within the NBA standards along with the NBA official weight of 625 grams, which is what I'm trying to do. If it's a small difference in filament density between the different filaments, you can probably get away with just doing some things like adding or subtracting walls and percent infill, or even slightly decreasing or increasing the diameter size of the basketball. But really what this means is that you'll have to offer multiple models of the airless basketball based on the type of filament that you're wanting to print with, and that's exactly what I went out to do. I started by making a design for both PEBA and Flex PLA filament because those have been the best two that I've tested so far. And then as usual, the first step was just getting those tedious supports off, which came off eventually on both of the basketballs. Next, I sanded them down just to get off any of the remaining support material and get rid of any bumps that might affect the bounce of the ball. Even with the sanding, it still stays pretty rough where the supports were on the basketball, and a few of you were asking me the best way to get the basketball smooth, and originally I was recommending a soldering iron and even a 3D pen to kind of smooth out those bumps and imperfections. But after some testing, I found the quickest and easiest way is to actually use an angle grinder with a sanding disc attached to it. Just be sure to not go too hard with it because I definitely caused some divots in this PEBA basketball that I'm smoothing down right now, so just be careful and be sure to wear safety equipment as well. Now that everything was smooth, it was time to test both the Flex PLA and the PEBA basketball that I've made. If you saw the previous video I made where I annealed a Flex PLA basketball and it resulted in a very durable basketball made out of Flex PLA, a few of you said that annealing just wasn't an option, so I made some changes to the 3D model that will hopefully make it so that you will not have to anneal either the Flex PLA or the PEBA filament with this new file, but that's something we're going to test right now. Before testing the basketballs, I went ahead and weighed them, and the PEBA ball weighed about 629.5 grams, and the Flex PLA ended up weighing about 636.5 grams. It looks like I'm going to have to make some small changes to the file before I release them. The first thing I'm going to test is the bounce of the basketballs, but I'm going to do something a little different. I'm going to follow the NFHS Rule 1-12-2, which says that the ball shall be inflated to an air pressure such that when it is dropped to the playing surface from a height of 6 feet, measured to the bottom of the ball, it shall rebound to a height measured to the top of the ball of not less than 49 inches when it strikes on its least resilient spot, nor more than 54 inches when it strikes on its most resilient spot. So what I did was I got a 6-foot tall piece of wood and I measured up 49 inches from the bottom and marked the 49-inch spot with a orange strip of tape. So just to recap, I'll be dropping the airless basketballs from the top at the 6-foot mark, and when it drops and rebounds, the top of the ball needs to go at least 49 inches in height to be considered in the official NFHS rules. So to start it off, I was just going to test a regular Wilson basketball. I was going to pump it up to make sure that when I do drop it, it was going to be within the standards that we're testing so that I can compare it to the other balls. And as you can see, the top of that basketball is definitely getting above that orange line, almost even the bottom of the basketball, which shows that it has a very good bounce. Next, we're testing the PEBA basketball, and as you can see, when I am dropping it from the 6-foot mark, the top of the ball is getting above that orange line. So it is technically within the NFHS standards, but as you can see, it does not bounce as well as a normal basketball. My hope is that the top of the ball would get past that orange mark, so I would call that a success. And now we're testing the Flex PLA basketball, and like previous testing, it just doesn't bounce as well as the PEBA basketball, which isn't really a surprise because you're paying a lot less, but you do still get a pretty good bounce, and it looks like it is just touching that orange line, maybe just getting above it, so I would also call that a win as well. Okay, now I'm going to test the durability of the basketballs, and I'll start with the PEBA basketball, and like I mentioned before, neither of these balls are annealed. I really wanted to try and test them to see if annealing is going to be necessary for the durability, and I'm going to put each of the basketballs through a 500 dribble durability test, and like you can see in the video, the PEBA basketball survived the 500 dribble test just fine, so the durability there looks pretty promising. Next was the durability test for the Flex PLA filament, and just like the PEBA filament, it survived all 500 dribbles in the durability test, so that is also promising as well. Okay, now we're going to go over the settings that I used to actually 3D print these files. I'm going to start with the Flex PLA settings, but before I get into that, I just want to let you know that I will release the 3MF file when I release the models so that you can directly import the settings if you're using Bambu Studio and a Bambu Lab printer. If not, I'm just going to go over the settings I used in case you want to try and transfer that over to one of your other printers. Just for this, I ended up using a generic PLA profile for the printing. I'm not going to go over this too much. I'm just going to display the numbers so that you can pause it and reference them if you need to, but it's just a generic PLA profile that I'm using for this. I'm going to move on to the quality section of the settings that I used. I print almost every airless basketball at a 0.2 layer height, and the other big one is to keep your Z-seam on random instead of aligned for structural integrity. Now I'm going to move over to strength. So the big ones here, I have about 4 wall loops, and it's the same with the bottom layers at 4, but the one that differs the most is the top layers. I have that set to 5. Because it's printing the top without supports, I've noticed you need that extra layer on the top to help compensate and keep the bounce the same throughout the ball. The only other setting really worth noting on strength is I have it set to a 50% gyroid infill, which is different from the 15% that I was going with in the past. 50% seems to do better with both the Flex and PEBA filament. Okay, now we're going to make our way into the speed section here. For Flex PLA, I have everything listed at 40 millimeters per second. I've printed them faster than that before, and I know it's tempting to up the speed, but the lower speed really helps with both the print quality and the layer line adhesion, so I would stick to a slower print speed, and the only big difference in the speed section is I set the bridge speed to 20 millimeters per second, which is important because there's a lot of bridging on these files, and it's very important to go slow on all those bridges. Okay, now we'll go over the support settings, and a few of you are asking me how I added the supports to the basketball, so I'm just going to go through a step-by-step here. If you go to the top, there's a tool called Support Painting. Once you click on Support Painting, you enter the Support Painting mode. And before I do any actual support painting, I like to go over to the highlight overhang areas, and I like to turn that to about 27, which seems to be a good amount of support for the curves of the basketball. And next I'm going to orient myself to the very top of the ball. I'm going to line up the seams so that I know that I'm directly on top of the ball, and then I'm going to alter the section view just a little bit so that I can reset the direction of the section view. Once it is reset, I can orient myself back under the ball, and I can decrease the section view until it's just outside of that red area that marks the 27% of the highlight overhang areas. From there, I'm going to select the Fill tool from the Tools menu, and if you left click on any part of the file, it will highlight the file in blue where you would like the supports. If you right click on it, it highlights it in red, which is actually blocking the supports. So be sure to left click on it and highlight it in blue, and when you're done you can reset the section view, and once you're happy with how that looks, and I am happy with how that looks, you can scroll back out and it will exit the support painting mode. And now when you go over to support, you can see the different support options here, and with the support painting it goes with the manual type of support settings that you use. So right now I have it set to tree manual, and that is just going to select the tree supports only on the areas that you highlighted in blue in the support painting. And after you slice it, you should have yourself some tree supports that will support the ball and hold it to the build plate for the rest of the print. I will just scroll down through the rest of the settings so that you can pause and look at what I have, but it's pretty much just the default settings. There's really not much of a difference in between the printing settings for both the Flex PLA and the PEBA filament. The big difference is I had to set up a custom PEBA filament profile in Bambu Studio based off of a PETG profile because they had similar melting temperatures and bed temperatures. The big difference is that I printed the PEBA filament at 250 degrees Celsius and the bed temperature was 100 degrees Celsius. I made a previous video dedicated to settings and what I used for printing PEBA filament, so I'll link to that so you can reference it. I'll also scroll through just a few things so you can reference that as well. But the big difference that I have between these two profiles is just the speed settings, in which I have the speed set to 44 millimeters per second instead of 40 for the Flex PLA, although you could do 44 for both of the filaments. Alright, that is the main overview of the settings that I use to 3D print the Flex PLA and the PEBA Airless Basketballs. A printing tip that I found helpful is to use a glue stick for both adhesion and as a release agent for when the Airless Basketball is done printing. The last thing I'll mention about our Airless Basketball files is that we plan on releasing all versions of our files to the public for personal use, but if you're considering doing any sort of selling of the Airless Basketballs or a commercial option for the basketballs, please consider signing up for our Make It Lab Patreon. We have a commercial tier that gives you permission to sell any of our current and upcoming 3D models that we release, including the Airless Basketball models. I'll add a link to the Patreon in the video description. Now that I have a model that both holds up with good bounce and durability, I can finally start to kind of move on from the actual files itself and start focusing more on the actual different types of filaments. If I missed something important or you think I should have used different standards for designing these Airless Basketball files, please let me know, and also be sure to let me know what kind of filament you want to see me try in the next few videos. I know this was a longer video than I usually post, so I appreciate you bearing with me all the way through it, and also because I'm coming out with new filaments and things that I'm going to be trying, don't forget to like, share, and subscribe, and I will see you in the next one.